Hello students, welcome to the next video on Analog Electronics 1. Myself, Gunjan Roy, in the Department of Electronics and Communication Engineering in Jamtech, Greater Noida. So we have started with the thyristor family, which is the 4-layer semiconductor devices, and in that the very first device we have talked about is SCR, which is considered as the parent thyristor device. After that, we will be considering in this video the Triac and Diac, the other thyristor family devices. So what is a Diac and what is a Triac? Basically, a Diac is a combination of Shockley diodes, 2 Shockley diodes, whereas a Triac is a combination of 2 SCRs. How they are becoming a combination of 2 Shockley diodes and 2 SCRs, this we will discuss in this constructional and other functional details. So the first thing we are talking about here is the triode, Triac. Why the name Triac is given to it? So the Triac comes from the word triode and AC switch. So the first 3 letters from the triode, TRI, and the last 2 letters given from the AC switch. So these are the devices which behaves as AC switch, and it has 3 terminals. So as we know that there are anode and cathode, so it is called triode because it has got 3 terminals, which are terminal 1, terminal 2 and a gate terminal. And since it is a 4-layer device, so it comes in the category of thyristor family, and it is used for power control function, and it offers AC switching. Okay, so if we look at its construction, which is shown in figure A, we can start with the layer P, N, P, N. So this is the first SCR, and the second SCR can be written as the NPNP. So this is the another SCR. So we can say that there are 2 SCRs connected back to back with 1 gate terminal, and the functioning of this device will be almost similar or analogous to the functioning of SCR, except that the SCR is having only 4 layers, whereas this has got 2 SCRs, where one works in forward region and the other SCR works in a reverse region or negative region. So here we have got the VI characteristic of SCR, and it is similar to the previous one which we have talked in SCR, that if Ig equal to 0, if the gate control current is 0, the maximum voltage is required between the anode and cathode, which is positive to negative. And then if Ig is increased, as the Ig increases, the voltage requirement decreases. Same happens in a reverse bias also. So it has got both the current conduction zones, which is in forward bias as well as in reverse bias. And here it is showing the symbol of a triode, which is showing the 2 SCRs connected back to back. Now this is the construction of Triac, having layers, different layers. This is P, N, P, N, and this is N, P, N, P. So this is terminal 2, this is terminal 1, and this is gate terminal. So after this construction and its features, which is almost similar to SCR, where it is working as 2 SCRs connected back to back, and therefore it is showing the conduction and VI characteristics in both forward region and reverse region. We would like to now mention about the advantages of Triac. So the first advantage is that they can be triggered with positive or negative polarity voltages. The second thing is they need a single heat sink of slightly larger size. So since they are power devices, they have the high ability of power handling, so they require a heat sink, and which is a single heat sink. Next thing is that they need a single fuse for protection, which simplifies their construction. And the last advantage is that in some DC applications, the SCR has to be connected with a parallel diode for protection against reverse voltage, whereas a Triac may work without a diode, as safe breakdown in either direction is possible. So these are the few advantages of Triac. And there are some disadvantages also with Triac, and these are that the Triacs have low change in voltage rating compared to SCRs. This is the slew rate ratings. So they have low slew rate. Second is that since Triacs can be triggered in either direction, the trigger circuits with Triacs need careful consideration. So they can be triggered in both directions, so it has to be careful triggering. Then the reliability of Triacs is less than that of SCRs. So SCRs are considered more reliable compared to Triacs, and that is why they are widely used in power switching or power handling devices. Okay, so there are some applications also of these Triacs. They are the Triac is a bidirectional thyristor, and whereas SCR is a unidirectional thyristor. So they have got few applications. The first is that in speed control of single phase AC series or universal motors. Second is in food mixers and portable drills. Next in lamp dimming and heating control. And the last is in zero voltage switched AC relays. So these are few applications of Triacs. After that we come to Diac, and the Diac word also comes from the diode AC switch, the first two letters from diode and the last two letters from AC switch. Why is it called diode? Because it has got only two terminals, a dianode or diode, which is anode and cathode. And Diac is a combination of two diodes. If we break the device in two PN junctions, so it is PN and NP. So it is a two diode device. Okay. It is a bidirectional AC operation switch and having two Shockley diodes and joined in parallel facing different directions to form the Diac. Okay, now this is the constructional features, and the construction of Diac looks like a transistor, but there are major differences. If we see at the construction only, it looks like a PNP transistor simply, but it has got a lot of differences. They are as follows. The first thing is that all the three-layer PNP or NPN are equally doped in Diac, whereas in BJT the doping ratios vary. The emitter is highly doped, collector is lightly doped, and the base is moderately doped. Then the Diac is a two-terminal diode as opposed to the BJT, which is a three-terminal device, definitely. The characteristics of Diac are as follows. First is the breakover voltage, then voltage symmetry, break back voltage, break over current, lower power dissipation. So these are the few characteristics of Diac. Although most Diacs have symmetry switching voltages, asymmetric Diacs are also available. Typical Diacs have a power dissipation ranging from half to 1 watt. This is the VI characteristic of a Diac, which is almost similar to an SCR, with the difference that it does not have a gate terminal or any control terminal to which we apply different current values, and depending on that we get different voltages. So here we have a definite breakover current, which is from 50 to 200 microampere in both forward and reverse regions. Thank you so much.